So in this question, we're going to look at how we can combine the equations for kinetic energy and the spring constant together. So the figure below shows the student launching a toy aeroplane. To launch the aeroplane, the student pulls on it to stretch the spring and then releases it. Just before the toy aeroplane is released, the spring has an extension of 0.12 meters. So calculate the maximum speed of the toy aeroplane just after its launch. And it tells you that its mass is 0.02 kilograms and the spring constant is 50 newton meters. Right, so the two equations that we're going to have to use are our equations for elastic potential energy and our equation for kinetic energy. So the first thing that we're going to do is calculate the elastic potential energy. So we can do this because we've got 0.5 times the spring constant, which is 50, then times that by the extension squared, so we've got 0.12 squared. So that would give us an elastic potential energy of 0.36 joules. We're then going to go and rearrange our equation for kinetic energy to go and give us V squared. Remember that the energy is kind of interchangeable with the kinetic energy. So we're going to have the kinetic energy divided by 0.5 times by the mass equals V squared. So we're substituting in the values. So we're doing 0.36 divided by 0.5 times by 0.02, which will give us V squared, which will be 36. Then finally, to go and work out V, we just do the square root of 36. So speed would be 6 meters per second. Right, so that's just one way that we can go and do one of these calculations where we're using two different equations.